Okay, so we're looking at section 2.4, graphing quadratic functions using transformations, and we're going to specifically look at graphing. So we're going to look at the difference between a parabola and an absolute graph. So let's look at a parabola, and this is an absolute. So parabola will always be a U shape, and an absolute function will be a V shape. So, well, the question is, how do I graph these? What would the function look like? So a function for a parabola is f of x equals x squared. But the absolute function would be f of x equals the absolute value of x. So we're going to do a couple examples on how to graph them. So let's do a parabola first. So parabola, if I am given a function that is like this, f of x equals x plus 2 squared plus 3. Well, if we see the square here, we know it's going to be a parabola. So that tells us right away that it's going to be a parabola. So if I were to graph this, and we're going to show the transformations, I'm going to graph it like this. So I'm going to have f of x equals x squared. I'm going to draw my little chart here. So x and y. So I'm going to use -2, -1, 0, 1, 2, and y equals x squared. So how I'm going to do is my x value is going to be squared. So -2 squared, -1 squared, 0 squared, 1 squared, and 2 squared. So that means -2 squared is what? Well, that's 4. -1 squared is 1. Because remember, when you square a negative, it becomes positive. 0, 1, 4. I'm going to erase this graph and move it over a little bit. So now we can graph it out. So I have 0, 0. Let's do this in a different color. Let's do this in pink. And then I have, let's see, the next one would be -1, 1. And 1, 1. And then we have 2, 4, -2, 4, and 2, 4. So we know it's going to be in a parabola shape, which is a U shape. It's going to look like this. So this is our first toolkit function. Now, if I want to graph the next part of my equation, I want to do my horizontal shift, which this is my horizontal shift or horizontal translation. So that means left and right on the x plane or on the x line. And so this is my first step. So our first step actually is technically to write the toolkit, but my first translation or transformation is the horizontal shift. So that means if I look at this and I see a +2, I have to know I have to do for the horizontal shift, I have to do the opposite. So that means I have to go, if it's positive, I have to go negative. If it was negative, I would have to go positive. So in this case, when it's positive, means I have to go left 2. So from the middle, left 2, I'm here. So now my new center is there. The other points will just follow in line. It's pretty easy to move them. So now we've moved them over 2. So that means f of x equals x plus 2 squared. So that's our horizontal shift. So that means we went left 2. Now, let's do the last graph. So the last graph includes my vertical translation. So that's 2. So my vertical translation. I keep saying translation. Transformation. Transformation. Silly. Okay. So now we're going to go up 3 because it's a positive 3. So from here, I'm going to go up 3. So let's show that visually. So from here, I'm going to go up 3. So 1, 2, 3. So that I have to move it up. So still on the -2 position, up 3. 1, 2, 3. So here is where I'll land up. And the points will still be in the same spot as before. So if I move this here, and that's 1, 2, 3, 4. So now we've graphed out our points. So now we know we have the full function. And now what I want to do is I want to graph my axis of symmetry and my domain and range. So I'm going to draw my AOS, my axis of symmetry. So my x here is -2, right? So that's my axis of symmetry. So my AOS, I'm going to be shape. I'm seeing translation function. Right? So that's my axis of symmetry. So my AOS is -2, or x, actually it's technically x equals -2. And then my domain is going to be forever left and right. So forever from -infinity to +infinity. And then my range is going to be bottom up. So my bottom point here, let's use my little pointer. So here's my bottom point. I'm going to go from here up. So my bottom point is, let's see. So my y value there is 3, right? Because that's where we went, 3. So I have to put a bracket because it's definitive. I know what it is. But the arrows are pointing upward, and I don't know when it's going to stop or if it's ever going to stop. It's not going to, so I'm going to have infinity. So I put a bracket because I know the value. I put a parenthesis because I don't know the value. So that's a parabola. Now, you could have a graph that has a negative in front. Let's say I put a negative here. And what would happen is the second translation would cause a reflection, which we've done it in class. So I'm going to do a quick example of that with a reflection using the same equation, but just with reflection. So -x plus 2 squared plus 3. So I'm going to show the graphs in order. So I'm just going to copy this graph. This graph is still going to be the same. Copy. So this is still going to be the same. This doesn't change. This is our first graph. So f of x equals x squared. And then my next graph will show the reflection across the x-axis. So that means it's going to be, since we're doing this step here, this is number 1. So if we don't have a negative there, the first step will actually be the horizontal shift. So we get -x squared. So all I did was flip it. And then do the horizontal shift in the reflection position. So we're still going to do the same direction. So since it's +2, I'm going to go left 2. So 1, 2. Yeah, can't draw straight lines. Okay, and then the last one, we just do the vertical transformation, vertical shift. So we go up 3 from there. So up 3, so we're on 0, 0, 1, 2, 3. Still on 2. make sure that's in the right place. It's not. Hold on. It's going to be at 1. There we go. Okay. And then you notice our axis of symmetry will be the same thing, but our domain and range will be different. So my axis of symmetry is still going to be 2, or minus 2. My domain still be negative infinity to positive infinity, but the range will be different. So range will be negative infinity to 3, because we're going from, with a pointer, we're going from further down here up to this point. And then let me write my vertex. My vertex would be here. So this point is negative 2, 3. And then what about here? So would this vertex still be the same? Yeah, it would. Negative 2, 3. So vertex would still be negative 2, 3. Okay, great. So now what we want to do is we want to do the absolute graph. So an absolute graph, again, will be in the B shape. So absolute. Go to an example of that. Absolute. So let me graph or draw out my X and Y. We can use the same points. And then, so what I'm going to do is I'm going to show the absolute value of any number is the positive result. So the negative will turn positive, and the other ones will be the same. So now the first graph is going to be similar, but it's not going to be a parabola. It's not going to be a parabola shape. It's going to be like a V shape. So negative 2, 2, negative 1, 1. The same thing on the other side. Now I have a V. So now I want to write a function. So we're just writing out our toolkit function here. So this is always the first step that you do for these graphs. And then now I want to do a function. So I'm going to do f of x equals absolute. So if you see these brackets, we know it's absolute. So now I'm going to do my first transformation. So we're going to do the horizontal shift again. Okay, so if it's minus 3, it means I'm going to go right 3, because we're going positive, the opposite of that. So if I go right 3, 1, 2, 3, we'll end up right here. So we just went right 3. And then the last transformation is we're going to go minus 2. So it means I just go down 2 from there. So let's just fix this line. Thank you. Okay, so this means that I'm going to stay in the same spot. I'm just going to go down 2 from there. So it's right here. So all I did was just go down 2. I'm sorry, I'm thinking of the last graph. Hold on. I flipped it upside down. That's not right. I flipped it because my mind was thinking about showing you the one with the reflection. Okay, so down 2. It's here. Sorry. Woohoo. So that's what I'll show in the next graph, is how to do that. So sorry, this is how it should be. Okay, so our axis of symmetry is going to be at x equals 3. And then our domain is negative infinity to positive infinity. And then our range is going to be, so I see in negative 2 to positive infinity. And then our vertex is an x of 3 and a y of negative 2. So that is how you do this problem. And then I'm going to show how to do it with a reflection. So I was thinking of that ahead of time, and I've caused myself to do it. Hilarious. Tells you when you focus on something enough, you do it. Okay, so I'm going to copy this guy again. It's our first function. Step. And then we'll draw the next step. So now I'm just going to do the negative version of that. So our negative version of that would just be the flip. And then we do our horizontal shift. I'm just going to copy this again because it makes it a lot easier. So our horizontal shift So positive 3. So it means if it's negative 3, it's going to have to go positive 3. So 1, 2, 3. So same thing as the last one. And then the last one, we want to do the vertical shift, so that's -2. So we just go down 2. Okay, we did it. So that's the last function. Let me write it out. And then, so what's our vertex? Our vertex, is it going to be the same? I think so, yeah. So 3, -2. Axis of symmetry, it's going to be the same again. So x equals 3. And then domain. And then range. Well, range is going to be a little different again. So we're going to do from negative infinity to -2. And that's how you do these problems. So this is how you would graph an absolute or a parabola graph.